Hello AP Statistics students. This video is going to go over section 1.1, analyzing categorical data. With any lesson that you are learning through a video, I highly recommend that you either take your own notes or you can print out the notes on the Schoology page and add any additional notes to it. Once you view this video, I highly recommend that you watch the very short example videos that are also located on the Schoology page. They go through pretty much examples of everything we're going to talk about, and they're very short. And then complete the assignment. So you can see the assignment is down here. At the end of the notes on Schoology, you'll find the answers for this assignment. So as always, please try the assignment first and then check your answers with the solutions posted on Schoology. Okay, so we're going to talk about displays of categorical data, bar graph, and some other types of graphs. We're going to talk about why some graphs may be misleading or deceptive, and how you can identify these when you're looking at graphs in the newspaper or online or in magazines. The two things that are probably most new to you, or brand new to you, are going to be marginal distribution and conditional distribution. So this is the main reason I suggest that you take notes or print them and kind of add some comments, some notations in there as we go through. And then finally, we're going to talk about two-way tables and describing the association between two categorical variables. So remember, categorical variables from the last video, from the last section, we're basically putting things into categories, so they do not have numerical values. All right, so here's two types of displays for categorical data, and you're familiar with both of these. There's a bar graph, and again, notice these are the categories along the x-axis. The y-axis typically will tell you, it looks like in this case, the number of people that have chosen these types of stations, and sometimes it will give you the percentage. We know this is not the percentage because it goes above 100. Another very common way, if your information is listed by percent, another common way to display it is using a pie chart or a circle graph. So here we can see adult contemporary, 11% of the people they surveyed chose that. 9% chose adult standards, and so on. And we're going to talk about a little bit later how to actually create an accurate pie chart. One last thing about the bar chart, you'll notice that the bars do not touch each other. If you remember from other classes, histograms are where the bars touch each other. But because these are not, the x-axis is categories and it's not numbers, and a bar chart, the bars are separated. Okay, then there's something called the pictograph, where they actually use some type of picture that relates to the scenario that they're describing. So let's read the problem. In the 2008-2009 regular season, basketball player Dwayne Wade averaged 7.5 assists per game and 2.5 steals per game. Explain what is wrong with the following graph and how to make it better. Okay, so we can see that this basketball appears to go up to about 7.5 for his assists, and this one appears to go up to about 2.5. So although the heights of the basketballs are correct, our eyes respond to the areas. Wade averaged about 3 times as many assists as steals, but the area of the basketball representing assists is around 9 times as big. So here we have the radius of each basketball, because 3 3/4 or 3.75 is half of 7.5, and 1.25 is half of the diameter 2.5. And if we put each of those into the area formula, we can see the area of the assists is 44 and the area of the steals is 5. So even though he only averaged about 3 times as many assists, This is a much greater area. It makes it look like he had quite a bit more assists than steals. So one possible way to correct this, make it so it is not misleading, is to, with a pictograph, is to just draw out the 7.5 basketballs for assists and the 2.5 basketballs for steals. Okay, that brings us to a two-way table, which we are going to see quite a bit of this year. A two-way table describes two categorical variables, organizing counts according to a row variable and a column variable. So here you can see an example of a two-way table. And here they're telling us where the data comes from. So the Pew Research Center asked a random sample of 2,024 adult cell phone owners from the United States which type of cell phone they own, iPhone, Android, or other, including non-smartphones. And here are the results broken down by age category. So our two-way table is age. It includes age and also type of phone. All right, marginal distribution. One of the categorical variables in a two-way table of counts is the distribution of values of that variable among all individuals described by the table. So here's what makes it marginal. Okay, so let's take a look at this. If we go down to the problem, letter A says, use the cell phone data to calculate the marginal distribution in percents of type of cell phone. So because we're talking about type of cell phone, we're going to take all the iPhone users and divide it by everyone from the random sample, and then just convert that to a percent. So we see that iPhone users make up 23.1%. And then we could do the same for Androids. All the Android users is 503 out of the total amount of people who answered the survey, 2,024, and that gives us 24.9%. And then you can do the same for other. All right, letter B says, make a graph to display the marginal distribution. Well, since we have percents, it makes sense that we could put that into a pie chart. And we see that other, which was more than half, makes up more than half of our pie chart. Android was right around a quarter, so that's a quarter of our pie chart. And then the iPhone was just a little less than a quarter. This data is from 2013, so certainly by 2020 this may look very different. But to describe what we see from this particular graph, we want to be very specific in our explanation. So in 2013, over half of all U.S. adults owned a cell phone other than an Android or iPhone. Overall, the iPhone and Android were very close, and we also know that people over 55 were very likely to own an other type of cell phone. Again, back in 2013. So one last thing before we leave this slide, I just want to point out that when we're talking about marginal distribution, it's always going to be divided by the total amount from the table. Okay, so here's just another example. These are the same two blocks from the previous slide. And we have young adults by gender and their chance of getting rich. You can find the data for this on page 12 of your book. And this says, a survey of 4,826 randomly selected young adults aged 19 to 25 asked, what do you think the chances are you will have much more than a middle class income at age 30? And then this table shows the response. So in other words, what do you think your chances of getting rich by age 30 are? And here's the responses. This is a two-way table because it describes two categorical variables, gender and opinion about becoming rich. Opinion is the row variable because each row in the table describes young adults who held one of the 5 opinions about their chances. Gender is the column variable, so we have female and male. The entries in the table are in the counts of individuals in each opinion by gender class. Okay, so how to examine the marginal distribution. So number 1 says use the data in the table to calculate the marginal distribution in percents of the row or column totals. So remember, marginal distribution is always divided by the total number. So that's going to be 4,826. All right, so we're going to do each row and also each column. So almost no chance, you would add up the female and the male that said they had almost no chance of being rich by age 30, which was 194, and divide that by the total amount of people surveyed. And you can see that's approximately 4%. Some chance, but probably not. Add the female and the male together to get 712. Divide that by the total respondents of the survey, and that's approximately 15%. And you can see for each row, rows are horizontal, we did that. We had the female and the male, and each one was divided by the total respondents. So here are all the percentages, and these add up to 100%. All right, then to do the columns, you would add up all the females, which was 2,367, and then divide that by the total of the table. And then we could do the same for male. Add all of those numbers together to get 2,459, and that gets divided by the total of the table. So we can see that from this survey, 49% were female that responded to the survey, and 51% were male. Okay, so now let's talk about how you can go about making a pie chart. So if we take those percentages from the previous slide, 4% of all the respondents thought they had little to no chance of becoming rich by age 30. So to put that into a pie chart, we want to make sure that the wedges or the sectors of the pie chart correlate to the percentages. So this is also called a circle graph. So we've got a pie chart or circle graph. And we know that circles have 360 degrees. So what we're going to do is we're going to change our percents to decimals. So I'm just going to move the decimal over 2 places. And 4% of the people said they had almost to no chance of getting rich by age 30. I want to make sure 400% of my circle, 4% of my circle, or 4% of 360 degrees is how big that wedge is. So for each of these, they get multiplied by 360 degrees. And that's going to tell us how many degrees are in each wedge or each sector. So 4% is 14.4 degrees. 16% would be 57.6 degrees. Then we've got 29%. Oops. Which is 104.4 degrees. And then finally, 22% is 79.2 degrees. And as a quick check, you should always add these up to make sure that they add up to 360 degrees. All right, so once you have these calculations, you would then use a protractor to make sure that wedge actually only has 14.4 degrees. The 16% has 57.6 degrees. So this would be made using a protractor. All right, a couple more slides to go. All right, now we switch from marginal distribution, which is divided by the total number of the entire table or everyone who took the survey, to conditional. conditional distribution of a variable describes the values of that variable among individuals who have a specific value of another variable. So we're going to select either the row or the column of interest, use the data in the table to calculate the conditional distribution in percents of the rows or the columns, and then we can make a graph to display the conditional distribution. And you can use a side-by-side bar graph to notice the differences in the heights of the bars, or a segmented bar graph, which we're going to look at. So here's the same data that we were looking at before. Now the problem says, based on the cell phone data, is there evidence of a difference in the distribution of cell phone ownership for the 3 age groups, and justify your answer? Okay, so we want to know, do different age groups prefer different types of phone? Is there a certain type of phone each age group prefers? We kind of already know the answer to this, but here's how it works. If I'm going to fill in iPhone users who are 18 to 34, you can look right over here. I'm going to take all of the 18 to 34 iPhone users, which was 169, and I'm going to divide that over the total 18 to 34-year-olds from this survey. So that gets divided by 517. So of all the iPhone users that all the 18 to 34-year-olds that responded to this survey, 33% of them use an iPhone. We could do the same thing for 35 to 54. I would take 171. That's going to go right here. 171 divided by 637. And I'm going to see that 27% of 35 to 54-year-olds use an iPhone. And then finally, I could look at 55 and older. There's 127 of them out of 870 who responded to the survey. So 15%, 55 and older, again, this was back in 2013, were using iPhones. And then we can do the same thing for Androids. So I would take the 214 18 to 34-year-olds out of the total 18 to 34-year-olds and see how many are using Androids. And then finally do the same thing with other. So we're not doing this out of the total, which would be the marginal distribution. We're giving this a condition. So we're basing it only out of each age group is what we're doing. Okay, so looking at the table, we could say based on the sample data, more than half of the 18 to 34-year-olds and 35 to 54-year-olds own an iPhone or an Android, while much less than half of the 55 and older group own one of these types. Furthermore, young people tend to prefer the Android to the iPhone, while older people show a slight preference for the iPhone over the Android. And again, this is from 2013, so if we looked at today's data, it would probably be drastically different. All right, on the previous slide, we mentioned a segmented bar graph, and that's what's going on down in the corner here. So oftentimes in AP Statistics, it just asks you to create a display, and you can pick which type of display that you want to create. So one of your choices is a segmented bar graph. So if I look at the 18 to 34-year-olds, for iPhone, because if you can see the key, it's kind of small. The blue is iPhone, red is Android, and green is other. So 33%, that blue piece is going to represent 33% of all the 18 to 34-year-olds. Androids came in at 41%. So if you take 33 plus 41, you get 74. So that red part is going to go all the way up to 74%. And then 26%, the top green part, represents other. Now when you add all of these numbers together, you get 100%. Same thing with 35 to 54. Add all of those, you get 100%. add all of these numbers, you get 100%. So you'll notice that each bar goes all the way up to 100%. But now we can see that in 2013, the older you were, the less likely you were to own an iPhone. The less likely you were to own an Android. But the more likely you were to own some other type of phone. So this is just another very effective way to display your data. Now, because the 18 to 34-year-olds, each age category adds up, each column adds up to 100%, we could make a pie chart for each age group to show which types of phones they were more likely to own in 2013. But what we could not make a pie chart for would be for iPhone, for each phone category, because you'll notice 33 plus 27 plus 15 does not add up to 100%. So I would not be able to make a pie chart strictly for iPhones or Androids or other. In fact, other is over 100%. But because my age groups each add up to 100%, I could make a pie chart for this group, a second pie chart for this group, and a third pie chart for that group. Okay, so we went over quite a bit. Some of it was review and some of it was new to you today, but we talked about different displays of categorical data, some ways that they could be deceptive or misleading. The two major points were the distinction between marginal distribution, which is divided by the total amount of your table or of your data, versus conditional, which is only divided by one of your categories. And then we talked about two-way tables. So, if you didn't take notes, I suggest that you print out the notes, or you can watch this video as many times as you like and take some notes. Next, you should watch the example videos that located in the Schoology folder. They're very short. And then finally, complete the assignment, and after that, check your answers. So as always, if you have any questions, you can send me a message or email me. These are important topics that we're going to be talking about all year long, and I look forward to discussing all of this with you further in class.